All right, cool. So this is our second webinar. We've done the last one on deployment practices, which was very, very technical, of course, very deep divey. This one is going to be a bit different. In this webinar, we'll focus on deepstream architecture patterns and best practices. More precisely, we'll focus on architectural patterns around data sync, so records, list, and the likes. Originally, it was intended to cover everything, but this turned out to be quite the agenda. So this webinar is about everything around how to structure the data flow in your application, how to create lists of things, how to optimize them, when to use set with a path, when to use listening, when to use splitting of records, and the likes. It will be a combination of high-level concepts and diagrams and low-level code samples, actually. All right? Bear with me, everyone. And so to kick off, we'll actually start with a little bit of code. Let me share this here. We'll start with a core concept when it comes to using records in deepstream, which is componentizing. Now, before we dive into that, one thing I would like to add, a lot of these things are based on questions that you sent in, and we try to incorporate as many as we can in this webinar. If you have any additional ones, please do feel free to interrupt me at any time and ask, and there will also be a Q&A section at the end. All right? So, when it comes to working with records, one of the core challenges is to keep them in sync, of course, and to manage their life cycle. Each record is an entity in its own right, meaning it has its own life cycle. It is being created, it is manipulated, it's being observed, you subscribe to properties within a path, or the record as a whole, and it eventually will also be discarded or unsubscribed from, or even deleted. Now, componentization is a concept that is perfectly well established across most front-end frameworks now. If you're from whatever school of thought, from React, from Vue, and the likes, you're already perfectly content with writing small functional components that do one thing and one thing well. And these records are designed to work well in these environments. Now, what I've got on the screen is the most basic combination of React component that shares and saves its state in a deepstream record. And as you can see, it maps to the lifecycle actually rather well. You create the record or retrieve it in the constructor, and immediately you subscribe to updates. Whenever the record changes, you set the state of the component. Now, likewise, whenever there's an incoming update, as marked in component will update, the state on the record is set. And all that's left to do now is, whenever you retrieve the initial state, just return from the record. And once the component will unmount, to discard the record. Now, this seems reasonably straightforward, but there are actually already a few gotchas in here. Let's look at some of them one by one. First off, let's start from the back. Let's start with record discard. Discard tells the server that you're no longer interested in updates for a given record. It doesn't do anything beyond. It doesn't delete it. It doesn't unsubscribe necessarily for you, although it does that too. Now, the important thing to understand about discarding a record is that it's an operation that is being multiplexed. In fact, the deepstream client uses an internal count. Whenever you call getRecord for a given name, it increments this count by 1. Whenever you call discard, it decrements the count. In the combination of both, you create this subscription count logic. Only when this count drops to 0 is an actual message sent to the server telling it that we're no longer interested. This sounds a bit strange, but think of it this way. Within your application, you're using the same component 3-4 times, each of which is bound to the same record. And we don't want to tell the server that we're not interested in updates for everyone just because one of them is closed, hence this counting approach. Now, the next state here is a little bit strange. Get initial state we use to return the record's current state. But get initial state within the React lifecycle might be called synchronously straight after the record is created in the constructor. Now, whilst that is true, that's perfectly fine for us. Get initial state will start up with an empty object, which we can use to populate the component already. However, once the update comes in, it will then trigger a component will update. It will then trigger a set state, updating the state. If the record already exists, this will happen synchronously straight away. So by virtue of adding a true flag at the end, we tell the deepstream client that we want this behavior to execute if data is already present. Now, the trickiest bit, however, or let's say the most potent bit about all this, I haven't addressed yet. As you can see, we're completely driving the component state of the record. We don't call into set state directly. We call into record.set. And likewise, we retrieve our entire state from the record, meaning the record becomes the single source of truth. Now, this is something that's super, super important. Why? Well, let me give you an example. For a single source of truth, imagine an app like this. I prepared this little thing here. Where is it? There we go. And we want this. All right. So we're using this kind of super simple post-it app. Two windows, and they're being synchronized by deepstream. Everything I type in one appears in the other. Reason straightforward. And as I move a post-it around, it updates position in the other window. Now, this seems reasonably straightforward. But how do you actually go about this? Well, easy enough, right? You start listening to mouse move events to create a tracking implementation. Whenever the mouse moves, you update the object on the screen. Now, the easy thing would be to take these mouse move events and store them in a document. And this document could easily be synchronized to a record that's stored on the server. All right? So far, that's perfectly fine. But what happens now is we have a second client. That client subscribes to the same document, and that in turn gets drawn to that client screen. But now things start to get a bit tricky. The second client, of course, also has the ability to move post-its around. So what do? We take the client's updates and also store them in the record, and then we synchronize the first document and draw this to the screen. And now we go into all these kind of tricky edge conditions around, well, we have a local state where I'm the one that initiates the move, so only the other person has to get it. Or we have a remote state where I have to update, but which has been initiated by me. And then, well, hold on, maybe I can distinguish between the two by introducing the flag and oh dear God, don't do that, basically. This was a long build up to telling you this is what not to do. No, instead, make your life so much easier by using records as a single source of truth. Every write is not written to the state locally, it's written to the record. And every time the record changes, the according representation on the screen changes, or the data, or whatever it is that you're building. By virtue of moving this state into one central location, you offload the challenges of keeping state in sync and maintaining it to deepstream. Deepstream is really good at that. It synchronizes it, it handles any kind of conflicts around. Bottom line, leave storing the state to deepstream and write and read from it. Cool. Now that we kind of covered state, let's look a little bit into collections and iterators. Or can I ask very quickly, actually? And by the way, by clicking this strange question button, you can actually talk or write or whatever it is you like to do. Did things make sense so far? Cool. All right, coming to that one then. Lists. We've looked initially into how a single component is created and how a single component handles and maps to a record lifecycle. But most frequently, you have more complex relational data. You have records that belong to many other records, or you have collections of them. Now, deepstream has a concept called lists, which you might be familiar with. Lists allow you to store an array of record names. So if you were to build this kind of infamous to-do MVC example, you would create a list, call it to-dos, and you would create records that represent a single entry within the to-do list. And this decoupling actually makes it that much easier, because now, of course, what you can do is you can have the individual data encapsulated in one record, and that record maps to one component in your front-end framework of choice. And you use a list, which is nothing but an array of references, not the actual records, not the actual data, just the references and the order they're in, to control the creation and destruction and order of these components. So here's what it would look like in code. This time I went with a view example. Apologies for that. Effectively, you take your list, you subscribe just as much to changes, and then you use it as an iterator. Now, pretty much every framework, every front-end framework these days, be it Angular, be it React, be it Vue, has some concept of passing either a property or a component on, or some sort of other variable on to a child component. And this is exactly what you do. As you can see here, with every single iteration, I pass the name of the record for a given component onto my child component. And then within that child component, I create and handle that. Now, the actual components themselves and the actual maintenance of the list, and this is important to emphasize, however, is up to you. There is no magic to lists. They have to be populated and maintained yourself. The reason behind is that lists can contain any combination of records. They can contain record names multiple times, and they have an end-to-end relationship to records. A record can be present in many lists. A list can have many records, also duplicates. They are intentionally left flexible to create more complex data structures. If you don't want that, there are a few other options. As you might have seen earlier, in naming my to-dos, I prefix them with a to-do and then a slash. By virtue of doing so, we create a kind of namespace within deepstream. And if you're using deepstream with a database connector, this namespace will map to a table in your database. So for any prefix separated by a slash, deepstream will automatically create a new table and populate it with your records data, which is a really neat feature if you're running any kind of data aggregation based on the records you store. Okay, so far, so straightforward. But how can we make it better? Well, let's look a little bit into optimizing our record usage. For that, I want to dive a little bit deeper into how deepstream actually works internally. So what I prepared is I'm running a deepstream server locally, and I've gotten this empty test page, which does nothing than create a deepstream client and stick it on the global namespace. Let me zoom in a bit here. Now, let's look at the first bit. Say I create a random record. Let's call it car. Or actually, let's make it more specific. It's a BMW. We're Germany, right? Car/BMW. Now, I have two ways to manipulate the data within this record. The first one is using the set command with any kind of data structure. For instance, say, all right, color, look. And of course, if I retrieve the content, it has stored this and synchronized it with the server. If I look at the network panel, I can see that deepstream sent an update command with the entire records data. This is a deepstream message internally. The first bit is the topic. R stands for record. Second letter indicates an action. U stands for update. In between, we have split characters, and the record name is car BMW. The site version is 1. And the last bit is the full data set. So if I extend this, color blue, and the amount of doors is 4. I can again see these are keep alive bits, that deepstream has to replace version 2 and transmitted the entire record data. Now, for records that are that tiny, this is fine, but for larger records, it doesn't really scale. This is why, whenever you can, I'd encourage you to use paths. Let me show you what I mean. So in my record now, I want to only set the amount of doors. So I could alter my command to say doors 2. As far as connected clients are concerned, the result is the same. However, on a network level, deepstream now sent a different message type, a so-called patch message, meaning it's only a partial update. Now, this message doesn't look that much shorter. In fact, it has the record name, a version, the path, and the fact that we want to set it to 2, and that 2 is of type number. However, it doesn't send the entire rest of the data. And as your record grows, this tremendously saves bandwidth. So whenever you know what exactly you're going to set, do use paths. We have extensively been looking into generating these patch messages automatically by doing tree comparisons on the set data. A little bit how you might know it from Angular's digest loops and the likes, that works out the deltas and only sends changes. And whilst this is greatly convenient, we found that the performance impact rarely really makes it worth it, especially for larger records. So we always opted for performance, and we recommend, if you know what you're changing, change only that. This kind of brings us onto another aspect as well, which is when you can, use mono-directional data flows. Now, what I mean by that is deepstream works not to the level of sophistication, of course, but a little bit like Git. It's built to cater for collaboration apps as well. Meaning, if you're building something like Google Docs, for instance, many people can work at the same time simultaneously on a relatively small data set. And these will handle write conflicts, merging, and the likes. But that does come with a cost. And in a lot of cases, what you actually wish to do is only send data downstream. And if a user interaction occurs, process it, and then add it in another place. So to give you an example, say you're building a horse racing app. What you want to do is you want to stream the results from the ongoing race, the places, the horses, and so on, in one direction, from the backend to the front end. And deepstream actually makes this so much easier and so much more efficient. In fact, one of the latest releases introduced a number of new APIs to make it even quicker. Let me show you what I mean. DS Record now, for instance, has a set data API. Set data is in many ways similar to just calling set on your record. But the difference is, in order to call set on your record, you have to retrieve the record for it first, meaning that deepstream actually has to load it, send it to the client, and then make changes. A lot of our users we found, though, are using deepstream as a data grid or as a streaming endpoint to consume massive amounts of messages from existing message bus, say Kafka or RabbitMQ, and just want to fan it out to the web. And for that, the overhead of requesting every single record on every single change and then manipulating it is significant. So rather than doing that, go for this API. Set data, BMW, car/BMW. Now we can go name Bobo. Not my most greatest moment, but you kind of get the point. Now, this has overwritten my entire car's data set, but likewise, set data can also be called into a path for partial updates, and it writes directly to a record without any additional steps. If you're running a pure mono-directional data engine, you can also go a step further actually than that. With the same update, we introduced a new feature called hot paths. Now, hot paths are a little bit tricky. They look like that, hidden at the very bottom of the deepstream config.yml file. Hot paths allow you to set record name prefixes, like for instance car/ in our example here, that you know will only be written to from your side. And what this allows Deepstream to do is skip the whole conflict resolution aspect, where it actually has to retrieve the latest version number first, and if there's a merge, check and so on. And instead, just simply lazily trust that the data is new and can be written and applied straight away, improving performance for mono-directional systems tremendously. But there's a bunch of other things you can do. And you can already tell pretty much all the optimizations we're doing here are around reducing the amount of data that goes over the wire. And that, in pretty much any real-time app, is the main challenge. We've seen this a lot when we look into building stock trading apps and the likes, especially with browser clients, but also in a bit more beefy backend clients. There will be a point where your connection just starts coughing and eventually going down. Deepstream is based on WebSocket or TCP, which has scale limits that just simply at bandwidth at some point cannot be overcome anymore. So it's always a good idea to keep the amount of data you send as lean as possible to maintain speed and efficiency. And one great way to do that is a concept called listening. Listening is, however, one of the trickiest bits in Deepstream to wrap your head around. Let me give you an example. Imagine you're building an app that provides weather information, weather updates for a given city. Now, clients come to you and they subscribe to different subjects, say the weather for Berlin or the weather for Malmö. Now, you are not the one that actually has the weather information. You get it from another cloud-based API. And in order to do so, you build a provider that connects to your API on one end and to a server on the other and streams data. But if you were to do it just like that, the task would be tremendous, since you don't know who's interested in weather. What you do is you would need to subscribe to any weather information for any place around the globe and push it into your Deepstream grid, leading to incredible amounts of overhead. What you can do instead is you can use our API that's called listening. Listening allows you to register a pattern of subscriptions that you're interested in. So for instance, you say, all right, anytime anyone subscribes to something that starts with weather, that's their star, I want to be notified. And that allows you to create active data providers that only send out data if and when it becomes necessary. So let me actually show you how this works in practice. And I pray I get this right in the first time, since there's always something I forget. All right. So 2 separate clients. Make sure we're connected. Nice, works. Now, in order to use listening, one of my clients would need to register as a listener. So let's start by doing this. Listening can be used for both events and records. We'll go for records here. So here's record listen. Which takes the pattern, say, again, well, let's put on example car / star, and the callback function. Callback function receives 3 arguments: the actual record name, whether a subscription has been made or removed, and a response. The response is an object with a bunch of methods on it that allow this client to control whether to accept or reject the need to provide for this record. Let's call this response. And here we go. And we keep all that simple here. We just look the arguments we're getting as a first iteration. Now, whenever I subscribe to anything that matches this, yeah, sorry, arrow functions. They knew it. No arguments. That's much more. And there we go. Now, as you can see, the nice thing is deepstream does keep state for you around these things. So I just refreshed the browser window and I immediately got the current matches from my method as well. And if you look at the response object, you can see 2 methods, either accept or reject. This allows us on the front end to tell whether something is listening to this given record. So on your record, you will see a flag as provider, and this provider and this flag says false on this given record. Now, if I change my listening function a little bit and actually accept the responsibility to provide data, response.accept, and as soon as someone subscribes, start providing. Let's get another car. I can now see that this record has been populated by this provider, and that it has a provider that actively provides data for it. All right, so this is one of the trickiest bits. Can I quickly ask questions around this? Please. Yeah. Sorry. Hey. Sorry. Yeah. There you are.
How do you subscribe to a specific record?
Sorry. Could you say that again, please?
How would you subscribe to a specific record on the front end, for example? The backend is listening for subscriptions.
I'm not quite sure I'm following. What do you mean by for a specific record? As in, okay, sorry. Right. I know I keep promising this, but next webinar, I don't know, recording booth. But that's what I mean. So I'm not super keen. I'm not so sure what you mean by a specific record. By virtue of saying get record and then providing record name, that is a specific record. Well, same thing. So it's probably worth mentioning. What I'm doing here is the same on the backend and the front end. deepstream doesn't distinguish between back and front end processes. You can use, obviously on the front end, you are kind of stuck with the Java SDK, which can also use Node.js on the back end. Or you can use the same techniques using a Java SDK, C++ SDK, or as of late, PHP SDK to write backend code. So all these, I'm demonstrating everything in the browser right now for convenience, but the idea would be that on the left-hand side, the listener and provider would reside on the backend, and the right-hand side would represent the front end that receives the data sent out. Does that make sense? Well, yes and no. Listening fulfills a bit of a different, sorry, just answer to Daval's question. Listening fulfills a different purpose than RPCs. Listening provides a continuous ability to send out data. The reason why there is an accept and a reject ability is so we can know whether data has actually been provided to your record. If you build an application that heavily relies on active data providers, as in a highly optimized environment you should, without this, you have no way of telling if there is actually something on the backend that is providing up-to-date data. You just get the latest version of the record, which might have been set a second ago, might have been set a day ago, and you don't know. deepstream is built from the ground up to facilitate microservice architectures with many instances of the same process doing the same thing, and load balancing between them. So with listening, you would have the same sort of data provider, say 2 or 3 times, And deepstream will load balance requests between them, meaning it will ask the first one at random whether or not it can provide this, and based on its reply, it will move on to the next. That, of course, is a bit similar to RPCs, but an RPC is a one-off question-answer workflow, whereas listening gives the ability to stream data to interested clients as it becomes necessary. To answer Adam's question, yes, but listening works the same for events. So you have the same kind of API, PS event.listen. And as far as the subscription is concerned, these are aggregated. So your listening callback won't be invoked for every client subscribing or unsubscribing to a subject that matches. It will be invoked once the first client subscribed to a given subject with is subscribed true. And then another client or another 100 clients can subscribe to the same subject and nothing will happen. And it will be invoked once again once the last client unsubscribes from that subject or disconnects. Okay, cool. So to answer Aya's question, a little bit off from that, but you can definitely use it as the only server. Deepstream is stateless, so at no point does it know about the sum of all the data that you have. However, as you said, as you interface with a database, you have two options. We recommend to store lists of things you need in, well, lists. That's very much what they're there for. You can, however, also very easily build a provider that connects to your database on one side and replies to remote procedure calls and similar to query the database and give you a full list of all available records, for instance. It's also probably worth mentioning there are some out-of-the-box providers. For instance, there's one for RethinkDB that allows you to issue searches using it, and that does all of this already automatically for you. But yeah, if you don't want to basically keep track of the data using lists, you would need to interface with the underlying data store, not Deepstream itself. Cool. All right. We also do an extensive general Q&A in just a few minutes. Actually, we're running to the last 50 minutes. Oh. No, sorry about my gazillion tech hiccups. All right, next bit. Now, a frequent requirement when working with any app is actually using your data. Makes perfect sense. You want to be able to transform data on the fly. It's a capability that has made streaming platforms such as Apache Kafka incredibly popular because you can actually run stream processing on them. Using the concept I've just shown, Deepstream makes a very similar thing possible. Let me give you an example. Say you're running a store that sells things. Kind of out of creativity, it's just things. All right. Each price for a given thing is composed of two aspects: a basic price and a discount. And this discount is different for every user, or say every user in a group. So what would happen here is a client would subscribe to, say, item 14 being the item ID, and append its username to the record name. And it would expect to get information about the item back with a price specific to just this client. Here's how that would work. You would add a data provider using the techniques we just looked at that ingests both prices and discounts and listens for subscriptions to item and the slash, aggregates and looks up the user's price and sends it back under this particular subject, dynamically created only for the time that the user is subscribed to it. The important thing here is to secure this, of course. Deepstream, as you might have seen, has a very, very extensive and very expressive permission language called Valve that allows you to perfectly set and ensure that users can only subscribe to their own price, subscribe to records containing their own username, and that only backend processors can actually access the underlying prices and discount sources. And this diagram looks reasonably straightforward, but this is actually a really, really important concept. Because what it allows you to do is create short-lived value-added subscriptions that only exist for a given user as they are interested in a subject for a given time. And this subject can dynamically be created on the fly and populated and deleted the very second this user stops caring about this given item. Right, which brings us to the end of the official bit and to the start of Q&A. Did any of this make any sense? What are your questions? How can we fit this into a larger architecture? Thanks. The listening bit is, yeah, it's always a bit tricky. It's one of the most advanced concepts, and it's also usually one that one only needs a bit later on in the architecture. But it's super, super potent, especially when used to create these dynamic subjects. Yeah, so to answer Pavel, that is true. The design choice behind that is twofold. Well, actually threefold, to be honest. In earlier versions of Deepstream, in Deepstream 1.0 effectively, which was purely node server, which is not any longer, it was possible to register a server-side hook that had the ability to transform data before it was sent out. And this allowed you to mix private and public data, for instance, in the same record, and then use this hook to strip out the private data and only send the public data out, and so on. And this was, of course, a really nice feature, but it is something, well, there's three reasons why we didn't continue with this. The first and most pushing one for us is that it is extremely expensive, and we worked, as you might have seen, quite extensively with Alex Holtman, the creator of micro WebSockets, in our particular micro WebSocket / Deepstream aggregation and binding bit. And in order to make this work, basically having this data transform hook in Node completely killed performance. We actually had extensive benchmarks around. It was 2,400 times slower. The reason, of course, is that we're right now compiling our message, sending it into CLAND, and fanning it out on very, very low network level. Using data transforms, C had to call back into Node for every single endpoint before sending out a message, which came with a tremendous performance overhead. This was the original motivation to strip it out. But on a more abstract design approach, there's two considerations. One is records ideally are an atomic bit of data. As far as Valve is concerned, the permission language, a record is a unit of granularity that is individually permissioned. All the rights are all the kind of permissions that you apply to a record as a whole, not to bits within it. You can, of course, control the data that goes in and check paths within that, but the user is either able to write a record or it's not. There is no subdivision beyond that. And this actually makes designing these applications a lot cleaner and more sensible. The other aspect is that using the pattern I've just described, it's actually perfectly straightforward to build data transformation logic or data aggregation logic. And it's also straightforward to build it using the exact same sort of paradigm that stream processing frameworks such as Spark or Flink use. which felt way more familiar to a lot of the backend developers using deepstream than having to write node functions. Arguably, with the trend and popularity of Lambda, this might have changed back again, tough to tell. But basically, there's no limitation of functionality. For some things, it just requires a bit of a different structure. Now, okay, so moving on to Joseph's question. In regards to offline capabilities, can I ask very quickly in that regard? When you say an internal deepstream server, what exactly do you mean? A server that runs on the same machine, or is there another layer in between? What's the typing actually quickly? The general answer on offline capabilities is perfectly possible. If the connection drops, deepstream will try to reconnect. But any change that you make in the meantime is buffered in a queue and is synchronized with the backend state as the server comes back online. What you can, of course, do is what you just described. You can embed a deepstream server inside the application and then use it as a proxy node to a deepstream grid in the cloud, which is a kind of cool setup, to be honest. There's benefits to that. It's not absolutely necessary. The client already handles offline events quite gracefully. It buffers events as updates from the server side come in. It compares versions and merges them or trigger merge conflict warnings and so on and so on. The only thing you have to do is, if you want to maintain state while the application is completely down, you have to add a storage hook, taking the queue that the client has accumulated whilst offline and dumping it, if you're in a browser, to local storage or same electron or to a file of sorts. Cool. To Adam's question. So this is something actually being asked quite often, and I can absolutely see how the different modes of describing and subscribing are a bit confusing. Let me give you an example. Say I'm creating my next car record. Is record car slash, what did we have so far? Fiat. By virtue of having called get record, I have notified the server that I'm interested in this record, so I have subscribed to it as far as the server is concerned. This is where things get a little bit complicated. However, there's a call that's called subscribe, which allows me to subscribe to a path within it, say color, and listen for updates. This subscribe is purely a client-side operation. So before I hit enter, looking back at our encryption protocol, we see I've requested or read a record. So we have record, create read, and here's the name. And the server acknowledged that, saying, all right, your record, I'm acknowledging the fact that you're from here on subscribed to updates to car fiat. And in the second message, it sends me its current state, saying record, read, car fiat, current version is 0 because I just created it, and its current data is just an empty object. So far, so easy. Now, actually, before I do that, 1 second. Now, if I request the same record a second time, absolutely nothing happens. Calling it a second time just returns a copy of the same record, an instance of the same record. So car is equal to car2, right? Deepstream has this very basic map inside, splits the same record back out if you want it in multiple places. However, you can see that usages has increased to 2 because now there's no thing. Now, once I start subscribing to path within it, And again, no message going over the wire. This is purely a client-side operation. Which now allows me, okay, so, and now of course, if I do set another value for the same record, you can also see, stick with my DOS example, 7, that this is sent to the first client, despite it only being subscribed to color, right? The only level of granularity, again, is a record as a whole, which can be as small as you want it to be. But calling subscribe and unsubscribe doesn't add a sub-level of granularity. So no need to create nested objects or anything, just to reserve that. I think it makes sense. Cool. In regards to Aya's question, updates that are queued up during downtime are sent as once. However, there's the deepstream client tracks them down into small individual packets. And you do actually have a great amount of control over that. Actually, screw documentation, let's look at it in code. To give you an example, you have all these very granular settings around how often it needs to reconnect, how often it sends heartbeats to make sure that the opposite side is still responsive, how long it waits until it gives up, and so on and so on. And you can tell it how many messages it can put into a single package that it sends via the connection, and how long it needs to wait between the sending of queue packages. And this allows you to tweak it quite a bit, since usually, especially when you're running a bit more on the networking layer, you always have this trade-off between getting as many messages out over the wire as possible, but also not clogging up the socket. And there is really no hard answer to that. It really depends on the exact requirements, and these parameters allow you to tweak in great detail the client behavior and how quickly it sends out these messages. Cool. Any other questions? Cool. So Adam asking, saying record paths is the order maintained if you set two paths within the same operation. Well, you can actually only set one path within a given operation, unless I'm overlooking something or misunderstanding. But if any kind of path, like front door dot left 0, or let's say 2 dot grep exists. So even with nested paths, it's only one operation. You can set complex objects, and you can override entire subnodes of your document of your object, but it will create one operation and it will send them out in the order it existed, each with their own version number. And if anything goes out of sync there, it will complain. So we'll do this a few times. Exist 2, exist 3. I can see how that's being sent out individually each time with a version incremented by 1. Sure. The official C# API, I'm afraid, yeah, that. So what we're actually working on is the C++ API, which makes extensive use of Swig, which allows you to write very thin wrappers around, which we'll be using in short term to publish a Python client, PHP client using the new HTTP API came out just a few days ago. As far as C# is concerned, it is something we're looking into. We're kind of evaluating how far we get with Swig. I gotta be brutally honest, it's not as high up as both Python and Go right now, which are the next big 2 ones. Cool. Okay, hold on. One thing at a time. When using file-based auth, keeping user file in sync is terribly hard, to be honest. File-based auth is something that we recommend using mainly if you have a kind of kiosk setup. So say public displays that everyone can connect to, and then a very small amount of data providers that have static keys, say like some sort of authentication tokens that allows them to identify themselves as data providers. So file-based auth, if you have more than like say 5 or 6 entries, probably not a perfect choice. So I'm afraid there is no great cluster synchronization mechanism for that, other than just injecting the file as part of your repo or deployment and the likes. For anything bigger, I'd really recommend HTTP-based auth and having a centralized auth server that can have any kind of complicated logic. Collections, collections are super hard since they're specific. Well, they're driven off the underlying database, and they mean an extension or a change to to every single database connector API. And we could take success customers extensively. Connections will land in deepstream Hub, our platform, very soon, because we are fully in control of the database and what it does. But in order to make it part of open source, it's not so much our connectors. There's a wealth of community-based ones, and either they become incompatible, or we kind of have to go around and make everyone update and implement this new aspect. So this has actually proven to be quite tricky to do for the open source bit. But again, deepstream Hub, stay tuned, going to be there very soon. Okay. All right. Sweet. All right, cool. If there are no further questions, and if there are, just quickly type yes and stop me. But cool. All right, cool, guys. Again, my apologies for the various technical hiccups along the way. To be fair, I've attended many webinars, and I have yet to see one that's absolutely smooth. But we're particularly bad at times, I accept. Thanks so much for holding out with me. Thanks so much for your great questions and for taking the time for this. We'll do another one of these in a couple of weeks. If you have any particular topic you're interested in, please do let me know. And we'll incorporate that as much as possible. If not, the next webinar might be super boring and will purely focus on security. Cool? And stay tuned, Deepstream 3.0, not too far away actually, still a bit secretive around it, but it will be interesting. All right, thank you so much, guys. Have a great morning, night, depending where you are. See you around.